Okay, hi everybody. Hopefully you can see me. Hopefully this stream is live. I'm still very new at this, so I'm not exactly sure what I'm doing. So please bear with me. Leave helpful comments below or in Google Classroom if you're joining me for one of my classes. So today we're going to be looking at CodeHS lessons 1 and 2. So I know a lot of you in my programming classes this trimester are new to programming. Some of you are returning, so you probably don't need this stream right now. But for any of you who are new to this, I know programming can be really intimidating usually. I think especially right now, the prospect of doing this alone is probably very scary for you. But I hopefully can get you guys to see that actually programming is really fun. It's a really nice distraction, especially during times like this. Now it's been already a few weeks. I know some of you have already burned through all of your video games and are just like bored to death with YouTube streams. It's just the same thing over and over and over and over again. And so I don't know, hopefully we can see this programming as actually like a fun little diversion, some problem solving, some puzzle solving, gets your brain active when, like, right now, just staying at home, I think it's like really easy. It's so tempting to just, want to stay in bed, especially say if you have a pet and a show that you're watching. But our brains feed on creativity. Our brains feed on having fun in an active way. So I don't know. Hopefully at least, some of you will try this out and you'll realize, okay, hey, there's something to this. Like you can feel powerful making your own stuff, making this machine sort of like come alive. There is a fantastic feeling that comes with that I just absolutely adore. Like I am probably never happier than when I'm just like really deep and invested in a programming project. It's a real different feeling than anything else in the world. So, and hopefully I can get that across to you. Otherwise, I don't know. Hopefully, at least it helps get you through and get a passing grade in really difficult school circumstances. So I don't know. Before I end up getting too dark, let's kind of get started with it. Let's take a look at what's going on there. Again, I am new at this, so I apologize in advance for any technical difficulties. So here we are in CodeHS. If anybody from CodeHS is actually watching, this is amazing. I love your product. I think this is a really great way to learn. And hopefully, this will be very helpful for those of you who are trying to do this, from home with very little supervision, unfortunately. So yeah, let's get to it. So we're going to be doing programming with Karel. I'm going to be starting off today with 1.1 and 1.2. And the idea is I'll kind of keep going up day by day and kind of looking at and more closely examining the examples and the slides that they put up there. Of course, you're still going to have to do the exercises on your own, no help there, or at least you're going to have to search a little bit harder to get that if that's what you're looking for. So let's take a look. Let's start off. So Karel the dog, Karel named after Karel Čapek, who was a Czech, I believe, science fiction writer. And yeah, so yeah, let's check out the video. Preview. Okay, so Instead of watching the video, right, you guys can watch that yourselves. They are also on YouTube. I highly recommend going and just actually watching through the video a couple of times. So I'm just gonna sort of go a little bit over the slides. So Karel the dog. Karel, he listens to your commands. Computers, I always like to tell my students in class that computers are like the exact opposite of teenagers. Teenagers have a lot of sense, right? They, are able to make sense of the world in very interesting ways without you doing it for them. But they don't like to follow directions at all. And whereas like computers are the exact opposite. They have zero sense. They're literally made of rocks. Literally, right? The processor, the brain of a computer is mostly silicon, a lot of plastic, a lot of metal, right? The silicon comes from more or less dirt and sand. The metal comes from rocks, and the plastic comes from oil. So it's a lot of, like literally no parts of that can properly think. But we can arrange it. We can put we can do the right, mix of chemistry to those things, and, design it in the right way and put all this stuff together. And then it can follow rules really well. Okay. It's dumb as rocks, but it follows the rules unbelievably well because that's what it's designed to do. So there's always like the kind of genie's curse element to this, which is why I think a dog is actually a really, really great stand-in for the computer because, dogs are similar to genies that way, that like a lot of times, like you can tell them, you can really teach them to respond to your orders and they'll do it like very, very well and very regularly, except sometimes, like when in an unusual situation, right, you tell them to do something and they interpret it in a wildly different way. So like with the genie's curses, you need to be very, very well aware of what you are asking it to do because it will do exactly what you tell it to do. Okay, so that's Karel. He moves around. His world is going to be kind of a big grid system, right? I'm coming, and if you're in my class, you know this, right? We're in New York and we live on a grid like this. So, he's got streets, he's got avenues that he's going to be able to move around. He can put balls down, he can take balls. So this is how we offer commands, right, in JavaScript, which is the language that we are speaking to Karel in, right? Programming languages are like languages that we come up with as a compromise to translate between the way humans talk and think into the way that a machine talks and thinks. And so, or like the way that it interprets things. So, JavaScript is a compromise. As far as these compromise languages go, it is a pretty friendly one. It's very widely used. And hopefully for most of you, this shouldn't be too bad, right? The commands always end with parentheses, right? Something can go in there, right? Depending on what the command is. A lot of commands, you don't need to give any extra details, right? You just say move, they move. Always forward. Turn left, turns left. Put ball, puts a ball down, right? There's no sense in which we are offering extra details. If we were, that's where those would go. And kind of like the end of a sentence, right? We are going to do a colon instead, or a semicolon instead of a period. It takes a while of getting used to, but eventually, like CodeHS will remind you consistently, and you'll be fine with it. So, right, what these programs come down to is, what's going on? So let's try out, or let's take a look at the first examples, right? What does a program actually look like, right? The program itself is just a big sequence of instructions. Okay, so you'll have to take that on your own, but we will take a look at this here. So first Karel program. So let's explore. So basically what's going on here. I'm actually going to delete this and like recreate it. Okay. Of course, if you open up CodeHS, you'll be able to see that original code as well. Okay, so let's take a look. So Karel is starting at the bottom left. And he is, actually, let me see. Can you guys see the cursor? I want to be able to indicate with the cursor. I'm not so sure that that is actually showing up though. It does not say whether that's happening in my streaming software. So I don't know. We will have to wait and see. If anybody uses OBS for streaming, please let me know if you know a way to do that. Okay, so what's he doing? He's starting in the bottom left. So in New York, I guess, you know, this would be maybe like 6th Avenue. And I don't know, I'm in Harlem, so let's say like 125th. So we'll start by making him move. So one thing I really like doing when I program is to just like click run all the time. Just make sure it's like sort of step by step I know what's happening. And then that way when I know if a problem, like if my code was working, I change a little bit, now it's not working, I have a really good idea what broke it, and which gives me a much better idea of how to fix it. Okay. So let's go ahead and run. And what happens? Well, you say move, he moves. It's very simple. So Karel is going to, every time you say move, he moves forward 1 space. Okay. Let's see what happens if we would say turn left, right? What does a command like this do? Let's turn that speed down. I always really like turning the speed up because I'm getting impatient. But if we look at what happens, or right, if you hit this like fast forward looking button, it'll take it through step by step. So right now he moves and he turns left. And what would happen if we had said move again? So we want to reset. And let's check it out. 1 command at a time. Move, turn left, move, bam. So basically he drives like a car. You tell him move, he goes forward basically a block, right? 1 space. Let's turn you off. We do not want any of those to be orange. That means it's going to pause when it gets to that line. And sometimes that can sneak up on you and you're like, oh my God, why is my program not running? Oh, because I put a break in my code, which made it kind of pause. So let's see, we want him to start at the bottom left. And then if we look at the picture on the left, I don't know, again, hopefully you can see my cursor, but I'm not confident of that. So Karel is going to start at, say, 6th Avenue, and then he's going to start going east, which on the screen is to the right. So Karel, we want him to move 1 space to get him to 5th, another space to get to 4th, and then now that he's on 4th, that's where a ball should go. So we're going to say put ball. And let's just make sure, right? Let's check ourselves, see that that's working. Move, move, put ball. Good. He's doing exactly what we want. So far, everything's great. Have him move to 3rd. Have him finish on 2nd. Move, move, put ball, move, move, and done. So, bam, just made our first program, right? All a program is a set of instructions that leads you to the result that you want. All right, so let's move forward. Okay, there's 2 exercises, so you guys should go ahead and try those yourselves because programming, it needs to be done, right? Like you can't just, you know, learn it. You have to do it. It's creative. Okay, so let's check out the slides. Again, this is available on YouTube. Just look up CodeHS, Karel 1.21. All right, so more about Karel. Let's get to know him a little better. So here's his world. Like I said, there's like streets, there's avenues, and we can number them. Streets are on the y-axis. They go up and down, right? These are the horizontal across kind of streets, just like we have it in New York. But kind of the opposite of New York, the avenues here actually go up as you go from west to east, whereas in New York, it's the opposite. They go up as you go east to west. So, you know, as a New Yorker, this is a little something I gotta kind of keep in mind, but it should kind of look like algebra class. We've got the 4 cardinal directions, north, south, east, and west. And like I said a couple minutes ago, he drives like a car. Like you can't make him move left. You have to point him left. He has to turn and then he will move in his new direction. So let's keep going. I kind of went over this stuff already. So let's try this one out. So they make a tennis ball square. I'm going to do the same thing again. Again, like if you don't like the way that I'm doing this, where I am like kind of deleting it and sort of actively reconstructing it, if you'd like me to maybe go over it in a different way, again, leave a comment here, leave a comment in Google Classroom. So let's start. So basically, again, we want him to basically go around in a little circle in the bottom left corner of the screen and lay a tennis ball in each of those spots. So let's see how we can make him do that. Well, first thing we want to do is put a ball down, right? Because there should be a ball where he is. Run, bam, tennis ball, we're good. After he puts that down, he should move forward. And then he should turn left. Now, hopefully, if some of you are paying attention, you might be asking me, wait, why make him turn left right now when we could just make him turn, like, when he should actually be putting a ball down now, right? That's what seems to make the most sense, right? Why not just put a ball when he is somewhere where he needs to put a ball down? And that is totally fine. That makes a lot of sense, right? We're just doing this very literally, but that's like, again, we're working with a machine. Machines are really, really, really good at repetition. You ask them to do the same thing over and over again, and they will do it without stopping. So the best way to think about this is to think about, well, what actions is he going to be doing a bunch of times? He's going to be putting balls down a bunch. He's going to be moving a bunch, right? Specifically, he's going to do those 4 times each. He's also going to have to turn left because if we just do put ball, move, put ball, move, put ball, move without turning him. Here, let's try this out. Right, make him do, you know, he'll put down 4 tennis balls, but he does it in a straight line. If we want him to make a loop, we're going to have to make him turn left a bunch of times. Well, why not turn right? Because he's a dumb dog. He doesn't know how to turn right. At least not yet, right? We still have to train him. So when I think about this, I want to kind of group all the things that need to happen together. Put ball needs to happen 4 times, move needs to happen 4 times, and for him to go into a full loop, he needs to turn left 4 times. And again, I really love copying and pasting. So Control or Command if you're on a Mac, Control C to copy, Command V to paste. So now, right, let's see what happens when I make him do these sets of 3 instructions twice. Okay, cool, we've got those. Let's add in a 3rd time, reset, run. There we go, we've got 3. He looks like he's poised to finish the loop. And there we go. Again, right, you did not have to put so much thought into this, right? If you just wanted to think about this like one command at a time, like put ball, move, put ball, turn left, put ball, turn left, put ball, right? If you wanted to think of it in those terms, that's fine. But the more we can start thinking like machines when we program, the more we can think how the computer's thinking, or think in a way that will make the job easiest or most sensible for the computer, the more we should do that. And the biggest way we can do that is by thinking in terms of repetition, and really by by sticking closer to the computer, we're really helping ourselves. I only actually had to write 3 commands. The rest I just copied and pasted, right? So I actually saved myself a lot of effort doing it this way. So, you know, at least you can be greedy about it. So anyway, these were the first 2 lessons in CodeHS. Tell me what's good. Tell me what I should maybe work on a little bit. Again, nicely, this is my first time trying the whole streaming thing, so let me know. I hope this was okay, and I hope you guys have a great rest of your day. I will try to do this again tomorrow for the next lesson or 2. I might just get through lesson 3 tomorrow because it's an important topic. I want to make sure to kind of do it justice. So have a good one, everybody.